Right, on 54, they want me to plot this point, and then they want me to find the rectangular coordinates of the point. All right, so the point is -3 with the angle being 120. So I know 120 would be like up here in the second quadrant, 30 past 90 degrees. And then the negative on the 3. So the 3 means I'm going to be on that concentric circle that's out 3 units. I don't think I have them all drawn in there. I didn't do a very good job. So this is like concentric circles. This is polar graph paper is what it is. And what it helps you with is the 3 part is which of the circles you're going to be on. So you're going to be on the circle with a radius of 3. Now what the negative does is this. And rather than being here, that would be, this spot would be 3, 120. Okay. That would be right there. The negative means you're going to be back here. Continue that and go backwards to 3. So that would be -3, 120. Now, when you go to do the rectangular coordinates, it's just going to be r cosine theta, r sine theta. Okay, it has to do with this triangle right here that would have been created, but we don't need to go through all of that. It's pretty easy to do. So you're going to put in -3 cosine 120. Okay, and then -3 sine 120. And cosine 120, that's on the unit circle. So you could go look at that. Okay, so it's like cosine of 60. So that'd be a 1/2. Let me think for a minute. That'd be at -1/2. And then this one is going to be sine of 120. 120 is here. The sine of it is going to be a positive square root of 3 over 2. Okay. And so your point is going to be positive 3/2 and then -3 square root of 3 over 2. So to the right, 1.5, and then down -3 square root of 3 over 2. And that would be the coordinates of that point. Same point, just with rectangular coordinates. Okay. All right. I wanted to look at a vector situation, just so we see it's basically all kind of the same deal. All right, the -4 is the horizontal component. The -3 is the vertical component. So you're basically dealing with a vector like that. It's a directed line segment, so it has the arrow on it. But see its connection, it just basically corresponds to that point, -4, 3. Okay, and so if you want to know the magnitude of that vector, okay, you basically just need to think about this being -4, this being -3, and this is the magnitude of the vector, the length of that right there. That's like the r that we had before, isn't it? So it's like the r from before. So I don't think of this as being all that different. So you do square root -3 squared plus -4 squared, and that's going to give you your r, which is the magnitude of the vector. 9 plus 16, that's 25. Oh, I probably could have figured that. I wasn't thinking that r would be 5, and that's actually the magnitude of the vector is 5. Then for direction angle, you need to get this right here. And so if you want to do the direction angle, you could use tangent to do that. Okay. And it's like you're getting this reference angle, really. So you can put the signs in there, but you have to make sure that you're getting your angle to be in the appropriate quadrant when you're finished. So we know the tangent of this angle right here, and I'll just call it theta, is going to equal, let me call it alpha, because it's really not the actual angle. I have to think a little bit about that. And that's opposite over adjacent. So that's 3/4. So I'm going to wind up going in then and doing the inverse tangent of that, right? So the tan inverse of this value right here is what I'm going to be thinking about. All right, now when you do the tan inverse of that, Okay, this is number 58. I was going to see if they wanted nearest tenth of a degree. So nearest tenth of a degree, when I go tan inverse that, it brings me back 36.86, like 36.9. So it's about 36.9. Make sure I was in degree mode. So that's about 36.9 degrees. Now, can you see that you're not, that's not the angle you're looking for? That's this angle right here. So your actual angle needs to be 180 plus that. See, that's the reference angle is 36.9. So theta is 180 plus the 36.9, which would give you 216.9 degrees. Okay. So that part you got to kind of reason out. Because tan inverse only gives you values that are in the first or fourth quadrant. You need to be over there in the third quadrant. So you have to be careful about that. Okay. All right. And then let's do, I think you'd be okay on some of those others. Let's go ahead and do 60. 60 is wanting us to write that in polar form. It's a complex number rather than a vector. Okay. But it's the same concept. It's just that I'm thinking about this axis as being the real axis, this being the imaginary. Then I'm going to come out -5 square root of 3 and go down 5. So here's the location. And I can think of it like a complex number, or I can think about it like a point right here when I'm doing it. And if I want it in polar form, that's when I'm going to do r, and then I'm going to have cosine theta plus I sine theta. So I need the r. So I need to get that triangle drawn in. Okay. And I need to find this piece right here. Now you might recognize that it's related to a common ratio and figure it out that way. Or if you wanted to, you could just come in and do r squared. It's going to equal -5 squared plus -5 square root of 3 squared. So that's 25 plus 25 times square root of 3 squared, which is 3. Okay, and that should have been a plus right there. And so that's 25 plus 75, that's 100. And you see how then r would just be 10. Okay, so this was really a 1, 2 square root of 3 triangle. All right, so r is 10. So that goes there. Now we need this angle that goes all the way around to here. Okay, so we can use the tangent of this angle, I'm going to call alpha, is going to equal opposite over hypotenuse. I mean opposite over adjacent, not hypotenuse. That can be reduced to 1 over the square root of 3. That might be something kind of familiar. And you can go to your unit circle and think about where would you be if your tangent was square root of 3 over 3 or 1. Okay. Square root of 3 over 3. Where would you be? So you could look at your unit circle to determine that if you wanted to, or you could, let me see how they worded it. They didn't talk about rounding to the nearest tenth and that kind of thing. So we might want to watch out about that. All right. So if it's 1 over the square root of 3 for my tangent, that means I need to be at pi over 6, don't I? So alpha would be pi over 6. That's the reference angle. But see where I'm at? Okay. I'm in the third quadrant. So that means I'm past pi that much. Okay. So my theta angle is pi over 6 plus pi. So that's 1/6 plus 6 pi over 6. That would be 7 pi over 6. So it should be cosine 7 pi over 6 plus I sine 7 pi over 6. So that's your radius, and that's your argument. All right, so that problem said to write the complex number in polar form, and they explicitly said to make sure we use radians for the argument. So we wound up with 10 cosine 7 pi over 6 plus I sine 7 pi over 6. Let me circle where that answer is. So right in here. Okay. All right, now the last problem I want to do is finding all the complex cube roots of 8. Now you might be thinking, well, the cube root of 8 is 2. That's the real cube root of 8, but there's a couple other ones if you allow complex numbers, so we want to look at that. So first off, this problem is a whole lot easier if you rewrite 8 as a complex number in polar form. So this is really 8 plus 0i. It's just all real, so it's like there's a 0i there. All right, so what you want to do is figure out then how to rewrite that so you have it in the form r cosine theta plus I sine theta. Okay, so that's what you're trying to do. So think about where you're at if you're at 8, 0. I mean, this is kind of like the point 8, 0 in the complex plane. So here we would be over at 8, 0. Okay. All right, so we can get the argument of that. The argument of that is going to be 0. Okay, so we know theta is 0. So we know this is going to be cosine 0 degrees. Let me see if they want, doesn't matter. And then this is going to be sine of 0 degrees. And then can you see that the radius of that would be 8? Okay. All right, so there it is written in polar form. And the reason I wanted it in polar form is DeMoivre's theorem for finding roots says that if you want the complex cube root, you could take the cube root of 8, then take your angle, okay, and we're going to be adding a multiple of 2 pi rotation divided by 3. Okay, so that's kind of the formula, and then you let n equal 1, not to start with though, let n equal 0, I mean, n equaling 1, and n equaling 2, so that you get all 3 of them. Okay, all right, so if we let n equal 0, what I like to do is think about the angle part for a minute. So see how that would be 0 plus 2 times 0 times pi over 3. That's just going to be 0, isn't it? Okay. And so that means that one's going to be cube root of 8 cosine 0 degrees plus I sine 0 degrees. Okay, so that's going to be 2. And then think about cosine of 0. Cosine of 0, isn't that 1? Sine of 0 is 0, so that part's gone. So you get 2 times 1 or 2. So that's the one you knew. All right, but now we're going to let n equaling 1. So that would be 0 plus 2 pi over 3, which is 2 pi over 3. So that means we now have it being cube root of 8, and then we need the cosine of 2 pi over 3, and we need the sine of 2 pi over 3, so we can plug those in. So think about 2 pi over 3. Okay, so the cosine of that's going to be negative 1/2. So we'll have 2, we'll have negative 1/2 plus I, and then the sine is positive square root of 3 over 2. So that would be negative 1 plus square root of 3. I like to put the I in front so that when I type it in. Okay, so that was just me distributing the 2. They asked for the answer to be in rectangular form, is why I'm doing that extra little step at the end. So there's one of your roots. Here's another one. And then the last one will come from here. 0 plus, now I'm going to put 2 in. That would be 4 pi. All divided by 3 would be 4 pi over 3. So I'm going to have the cube root of 8. I have to do the cosine of 4 pi over 3. And then I sine of 4 pi over 3. So think about where you are with 4 pi over 3. You're over there in the third quadrant. So the cosine is negative 1/2. The sine is negative square root of 3 over 2. Cube root of 8 is 2. Distribute the 2 and you get -1. And then it'll be minus square root of 3i, or I square root of 3 if I put it in front. All right, so there's your third one. Okay. All right, so that's the problems on the final exam review that I thought would be worth taking a look at. And if you have other questions, we can do those during office hours.